Okay, so now we are discussing the problems, solving the problems on the constant head test and falling head test. Okay, so this is the problem number first. A specimen for 120 mm specimen 120 mm in a diameter and 360 mm long is tested in a constant head permeameter. A flow of 260 centimeter cube is measured in 300 seconds when the constant head difference between the tapping points 250 mm apart is 70 mm. Determine the coefficient of permeability. Okay, so what is the given data? So first of all, a specimen having the diameter d equal to 120 mm. From that we can calculate the area. So calculate the area equal to pi by 4 into 120 square, that is d square. Then the length of the specimen is 360, so L equal to 360. Okay, and the flow of 260 centimeter cube, the flow that is what is given, that is discharge. Okay, so what is the unit of discharge? Centimeter cube per second. Okay, so this 260 centimeter cube is given, that is q is 260. Okay, and per second, the second is 300, that is 260 upon 300, because the unit of discharge is centimeter cube per second. So 260 is the flow, that is centimeter cube, upon second is 300, that is 260 upon 300, that is 0.87 centimeter cube per second. Then here difference between the tapping point, okay, tapping point, that is 250 mm apart is 70 mm. Okay, that is hydraulic gradient equal to h upon L. So I by L, so that is or we can call as h1 by h2. Sorry, head difference, that is hydraulic gradient, is which is dropping from 250 mm apart is 70 mm, म्हणजे from 70 mm to 250 mm, 70 mm पासून 250 mm पर्यंत काय करायचं आपल्याला मेजर करायचं आहे. दिस इज अ हेड डिफरन्स, दॅट इज दिस इज 70 and this is a 250. So I equal to this 70 upon 250, that is 70 by 250, that is 0.28, that is 0.28. So K equal to, what is the formula? K equal to QL upon AH into T, or K equal to Q upon IA, Q upon IA. So Q is 260 upon 300 into 10 raised to 3, okay, into 10 raised to 3, because it in we want in centimeter per second, upon I, that is here, that is 70 into 250 into pi by 4 into 120 square, that is area. So we get the permeability as 2.28 into 10 raised to minus 3 centimeter per second. Or we can also calculate permeability K equal to QL upon AH into T. Okay, so Q is 260, that is 0.87, K is Q is 0.87, length of the sample is 250, which is given. Then the area is pi by 4 into 120 square. Then the head or hydraulic gradient is 0.28, and time, the time is what is the time? That is 300 second. Okay, so put all this value, we get the answer. Okay. Then the second problem, it is for falling head permeability test. In a falling head permeability test, on the specimen 65 mm high and 5250 mm square in a cross sectional area, the water level in the standpipe 90 mm in a sectional area dropped from height 650 to 200 mm in a 210 second. Find the permeability. Okay, we know the formula for falling head permeability test. What is the formula? That is 2.3 AL upon AT log to the base 10 H1 by H2. So 2.3 A means the area of the standpipe, that is 90 mm square, okay, which is given 90 mm square, which is given, okay. This is the area of standpipe, this is small a. L, that is the length of soil sample, that is 65, that is height, that is length. Then upon capital A, that is area of a soil sample, that is 5250, okay, into T, that is time, okay, it is drop in 210 second. Then H1 means the initial head, head is 650 and H2 is the final head, that is 200 mm is the final head. So our permeability is 6.25 mm per second.